Rain1290 with you to bring you another thunderstorm risk analysis for Eastern Ontario to Southern Quebec and portions of the Northeast. This will be for mostly pre-dawn of June 28th, 2025. So without wasting any more time, let's get right into it. But really what I want to draw your attention to is this dashed beige line that's in the Northeast and Eastern Ontario to Southern Quebec. So originally it's somewhere up here in Northwest Ontario, Northern Ontario, and sliding southeast towards the Northeast US. So this feature will be the prominent feature, I think, and to some degree this warm front that's extending in Southern Ontario to Western New York. So collectively, these features will help to produce scattered thunderstorm development in Eastern Ontario to Southern Quebec and much of the Northeast. And these thunderstorms are heavy thunderstorms, which will contribute a large amount of rainfall in a short period of time during the pre-dawn of June 28th. So really what we're looking for in these maps, and as you saw in previous videos, are these amplified areas of lift represented by yellows to purples, and reds and purples being the highest amounts of lift. Right now we're at the mid-afternoon of June 27th, so around 2 p.m. So let's go towards the end of June 27th and more especially into pre-dawn of June 28th. So we're seeing these higher amounts of lift starting to reach Eastern Ontario to Southern Quebec. And this is partly related to that warm front that's starting to eject to the northeast. So we are seeing that increased amounts of lift. Okay, so more importantly, let's look at 500 millibar vertical velocity. So this is another source of lift. And why I stress this in particular as compared to surface convergence is that, as you might recall from this chart that I showed, the synoptic chart, it showed this dashed beige line that's representative of a shortwave trough that is sliding from the northwest towards the southeast. So it is a potent trough, so I want to emphasize this more as our dominant source of lift. So let's look into this time series. So right now we're in the morning of June 27th, and you're already seeing these colorful areas, so representing the largest amount of lift. But let's go further, and you'll actually see this starting to reach Eastern Ontario to Southern Quebec along this elongated sort of pattern. So that's representative of that shortwave trough. In fact, this whole area is representative of that. So this is 2 o'clock in the morning on June 28th. What we were looking at before was June 27th, but now we're in June 28th. So 2 o'clock in the morning to 5 o'clock in the morning, and you're seeing this area under the influence of some pretty significant lift from that shortwave trough. So a pretty enormous contribution here. So I think this will be the most important factor for scattered thunderstorm development during this time. Okay, so I elected to forego looking at low-level lapse rates and went straight ahead to mid-level lapse rates. This is mostly because the timing of this event is mostly during pre-dawn, so low-level lapse rates are less influential. That's simply because we don't have sunshine during the pre-dawn period. But as a substitute, we need something else to drive instability during pre-dawn, and one of those things is the mid-level lapse rates. So let's go forward to the timing in question into pre-dawn June 28th, as I mentioned. And this is 5 o'clock in the morning on June 28th, and we're really not seeing all that much in Eastern Ontario to Southern Quebec and much of the Northeast. You do start seeing some steeper rates, as represented by these grayish colors, grays to even greens, but we're not seeing all that much in Eastern Ontario to Southern Quebec. So we're not getting that much support from the mid-level lapse rates. So normally, this would be a red flag for me to consider a thunderstorm risk during pre-dawn when these are absent, when you have pretty weak mid-level lapse rates. So what I mean by weak is anything under 6 Celsius per kilometer cooling rates at mid-levels. So we're, in this case, getting barely 5 to 5.5. So that, for me, is grounds to discount a thunderstorm risk to some degree. But because that lift that I showed before with that shortwave trough is so strong, I think it will help to overcome the lack of mid-level cooling. Now let's look at the dew point temperature, since that's also another source of instability that is important during the pre-dawn period. Okay, so turning our attention to dew point temperature, which is a representation of humidity. So really what we want is for more and more moistening to help improve instability. So the greatest amounts of humidity are located farther southwest, which makes sense since our warm front is located in southern Ontario to upper Pennsylvania. So going towards pre-dawn June 28th, since that's the period in question, we're actually seeing that moistening taking place in Eastern Ontario to Southern Quebec, as represented by these darker shades of green. So these represent dew points of roughly 58. So this is late evening, June 27th, actually. And that's close to 15 Celsius, which represents moderate humidity. Before, on June 27th, we were seeing lower amounts of humidity. So we're getting into that stickier sort of atmosphere at this point. So now going into pre-dawn. So now this is 2 o'clock in the morning, June 28th, and we're still seeing pretty steady amounts of humidity. And then going towards 5 a.m., a similar situation. Not a huge amount of moistening, but it is large enough to generate sizable instability for these hours. Okay, so I pulled up this SKU-T log P diagram just to give us an idea of what the environment looks like and to consolidate everything we looked at previously. So this is taken from the west end of Montreal at 2 o'clock in the morning on June 28th, since that's the time period in question. And you can see how this green line, this dew point temperature, right? So this green line represents how dew point temperature is changing with increasing altitude, and this red curve represents how the environmental temperature is changing with increasing altitude, right? So altitude is measured in millibars based on pressure levels from the surface, which is 1,000 millibars, going all the way up past roughly the tropopause and beyond. So at the right, we also have these wind barbs, right, which represent wind speed and direction based on how these wind barbs are oriented. So firstly, during this time frame, and also going forward into 9 o'clock in the morning on June 28th, a very saturated tropospheric profile. But if you look carefully in the lowest 150 millibars, which is from the surface to about 850 millibars, because that's our boundary layer, we do have some instability that's able to generate itself over here, just based on this dash curve. If you follow it down into the lower troposphere, you actually see that to the right of this red curve, representing a zone of instability. So I think this instability will reach roughly 500 joules per kilogram for CAPE. Now, at the same time, we have these wind barbs that are configured in this orientation. So we have this veering component because at the surface, we have winds coming in from the southeast, as shown by this wind barb at the surface. So you see it's pointed in a southeasterly kind of fashion, and then that veers towards a southwest sort of orientation by the time we get to 850 millibars and going up. So there is a sizable amount of veering taking place, and not too much of a speed shearing component since the wind speeds don't change all that much with increasing altitude. So that's pretty uniform. So overall, just eyeballing this, there isn't that much potential for significant thunderstorm organization, so I don't expect this to be particularly significant. However, it is enough for at least some organized thunderstorms to take place, even though they won't be sustained for a huge period of time. But I think what's more important about these thunderstorms is their ability to cause significant flooding in these regions altogether, since we are getting a large amount of rain altogether from convective rainfall. So these thunderstorms will be able to contribute to that by adding a significant amount of rainfall at the local scale, where rainfall is already most substantial. So I think that will be the primary hazard with these thunderstorms altogether in this environment, and not just for the pre-dawn, but also acting as a big contributor for this weekend's rainfall situation altogether. So from Saturday and into Sunday, and later Friday previously on June 27th. So also based on this profile, just looking at the 500 millibar temperature, which is somewhere around -8 to -9, not just the 500 millibar temperature, but closely surrounding altitudes as well. So this does suggest to me that lightning frequency is generally low, but it does have that potential to reach moderate frequency during the pre-dawn period. So as we go forward towards pre-dawn June 28th, you're seeing these larger amounts of rainfall, 24-hour rainfall amounts taking place. So this is pretty large for 24 hours. So the red colors down in southern Quebec, you're seeing almost 3 inches taking place in a 24-hour period. Roughly around in the Montreal area, I think we'll see 1 to 1.5 inches. Specifically, I think we'll see about 1.75 inches, which comes out to 32 millimeters to as much as 42 millimeters. But again, these amounts could be amplified because of the thunderstorm situation during the pre-dawn period in not only the Montreal area, but Eastern Ontario into upstate New York and going north of the island of Montreal. So I think these are largely coming from thunderstorm contributions. Okay, so since our shortwave trough is located in this regions represented by this dashed line, as I showed in that synoptic chart before, and then this would be evacuating farther southeast, right? So really what I expect to happen is for thunderstorms to develop along this zone where lift is starting to increase pretty rapidly along that shortwave trough. So as I showed you, that shortwave trough is generating some pretty large amounts of lift as it ejects southeast. So these thunderstorms, I think, will favorably develop in scattered fashion, as I mentioned, and moving at a decent speed as they move to the southeast, largely affect eastern Ontario to southern Quebec and upstate New York along that boundary. So these thunderstorms will develop into multi-cell families, some of them capable of moderate lightning frequency. But again, I think the dominant hazard will be the substantial rainfall rate, since a large amount of rain will be coming from these thunderstorms in a short period of time during the pre-dawn period. So ultimately, they would be moving in this sort of direction in tandem with that shortwave trough. So if you made it this far, thank you once again for your attention. Always appreciate your attention. And if this video was useful to you, if you found it insightful, I encourage you once again to subscribe to not miss out on upcoming forecast videos, not just for thunderstorms, but forecast in general. So to that end, I will leave you with this playlist into forecasts and outlook. So if that's of interest to you, please check out that playlist. That playlist will only grow in number as I continue to create more of these videos. And on the right, you'll see some footage from the Montreal area in terms of thunderstorm documentation. So feel free to check that out. It includes all thunderstorms that I've documented since 2008. So once again, thank you very much, and I'll see you in the next video.